Hi, my name is Wang Jihin and we are from Group 10. So our project title is Smart Spike Sharing System, and let me introduce our problem statement for our project. So the first problem statement is lack of real-time monitoring of bike availability of each station. Then the second problem statement is difficulty in locating nearby bike station for return. And in the end, the user need to find the bike station on their own, which time-consuming and inefficient. And the last statement is difficulty in determining when bikes should undergo maintenance or service upon reaching the specific usage. Now, I'm going to talk about the objective of our project. So the first objective is to implement smart bike sharing system to encourage the use of bicycle to reduce the carbon emission and traffic congestion. Next is to improve the urban mobility and add on an alternative choice to traditional mode of transportation. And the last objective is to provide a visualization of data for tracking the bike travel distance so that we can know when the bike should send to maintenance to prevent any unexpected breakdowns and reduce the downtimes. Next, this is the architectural diagram for our proposed solution. So now I will demo on how to create the database to store the data. And in our case, we'll use the DynamoDB to store our data. So first, we'll search the DynamoDB in the management console search bar. After it redirects to this page, select the table on the menu and it will redirect to a table page. Then we just click on the Create Table button. Then we will redirect to the Create Table page where we need to enter the table detail, which is the table name, partition key, source key, and other setting. So in this case, we just select the byte data as our table name, and our partition key will be the byte ID. So the source key, we just leave it as blank, and the table setting just leave it at default. So then we just click the Create Table button, and just for AWS as to create a table. So after it successfully create a table, it will show a pop message, which means that it is created successfully. And here is the table that we created just now. So this is the information of the table, and we need to explore the table item. Just click this button to explore all the items inside the table. That's all for me.
Now I will be presenting for user authentication process. For user authentication process, we are using Amazon Connector to authenticate user for sign in and sign up. When users are accessing our application through an internet, it will direct user to the Amazon Connector built-in service for sign in and sign up. So let's go through for Amazon Connector. Before accessing to the Amazon Connector services, we have to create a new user pool. After that, we will choose Connector user pool by default and choose all the sign-in attributes. After that, for this multi-factor authentication, we will disable for this case. So next. After that, we have to create our name for our user pool. For example, I'm choosing Bikes pool. And we have to check the hosted authentication page, which is using the Connector hosted UI. It will be using the Amazon built hosted sign in and sign up features. And we can choose the domain name ourselves. We can use either Connector domain or custom domain. For this case, we are using Connector domain. For example, I'm choosing for Bikes demo. Okay, so this is available and we can use this Connector domain for our sign in and sign up pages. And for the app client, we have to create for public client and enter for a name for this. For example, by clients. And for this callback URL, we have to put the URL that it will direct user to the page after sign in and sign up process. So as we are using localhost development, so I will be put the file path /test.php/callback. At the final step, we just have to review our configurations and create for the user pool. We just go through all the configuration, whether it's set up correctly, and if there are no issue, we can go to create user pool. Once we have done creating the user pool, we can show that bikes pool is successfully created, and it will listed according with our configuration setting, and we can go through app integration and choose for our app client. For this app client, we can use the view the hosted UI here. And this is the output for the sign in page. And for sign up page, the interface will be look like this with our attribute username, email, and also password. So user can go through sign up processes. For example, I'm choosing demo test, and email will be demotest@gmail.com. And we have to input a password for this. After signing up, we have to go through our user pool created just now and find for demo test. For this demo test, we have to do a manual confirmation for this account. Yeah, I've successfully confirmed the status. So let's go through the sign-in process again. And for this sign-in, we just have to put demo test, the username, and for password. And the sign-in process is successful. And it will show the map by default. For the map feature, we are utilizing Amazon location services here. For Amazon location services, we have to create a new map. And we have to enter a name for our map. For example, I'm using demo app, and I'm using S3 navigation for the map style. And for API key, we have to create an API key for our map. For example, I'm using map demo API for our name, and we just hit on create map. And it mentioned that the demo app maps and API has been successfully created. To implement this demo app in our application, we have to go through API key and copy the API key value here and include this in our source code here. And we also need to indicate the region and also the map name. And that's all about the API key, and we can launch our web successfully. So here's the output for our web. After user login, it will redirect user to this map location. By default, it will show the Yuta Gambar map here. That's all for our presentation for location services.
So now I will demonstrate how the AWS IoT Core works. First, we will need to connect a device. We will need to follow all of the steps provided by AWS IoT. After all of this, then we will successfully connect our device to the cloud. We can view our devices in all devices things. You can see that I have already connected a device called Byte1. So this Byte1 will be used to demonstrate the message passing between the byte and also the cloud. I will use this to demonstrate all of them. Now we will start the demonstration for the message passing from the byte to the cloud. So we will first need to subscribe to a topic called byte data. After we click subscribe, we can see that this is the message payload from the byte. So we will modify the message payload to demo how we try to rent a byte. So this is the message payload. It looks like this. If we try to rent the byte, the action is rent, and the byte ID is 001. This is the byte that we are trying to rent, and we publish it. You can see it's here. So in order to let this message to be passed into Lambda for processing steps, we will need to configure the message routing. We can configure it in the message routing rules. we will set up a rule to trigger the lambda. So it means that if we try to publish a message from this topic called bike data, it will trigger the lambda. And then the SQL statement used inside is the select all from bike data, which means all of the data from the message payload, which is the action and also the byte ID, they will be passed into the lambda for processing. So in the lambda, we can view our function. I've created a function called save byte data. The main usage for this function is to save the data passed in from the byte through the AWS IoT Core into the DynamoDB. So first we will need to add a trigger. We can set it up in the configuration triggers. You can see that I already set up a trigger from the AWS IoT Core called byte data store. So we will view the code. So in our code, we can see that the table that we are going to update is called the byte table. And there is two kind of action. The first action is to rent. If the user try to rent, then these are all the processing steps that will be done. We will check the byte availability. If it's false, then we cannot rent. And if it's true, then we can rent successfully. And the second one is the action to return. If we try to return a byte, it will update the database based on the usage of the byte, the trip, the location of the byte, and based on the byte ID. This is the processing steps. So after the message passed through this function, it will go to the DynamoDB. So we already published the action to run byte 001. We'll check it in the DynamoDB. So we will check it in the byte table. So in the byte table, we can see that we have many bytes inside. We tried to run byte 1 just now. The availability will become false. And then we will try to return the byte 1. So the action is returned, the byte ID is 001, and the trip distance is 1,000 meters, and this is the current location of the byte. We will publish this. After we publish, this will also be passed into the function just now, and also it will go. It will be saved into the database. So we refresh. So now the byte availability becomes true again, and the byte usage increased by 1,000. Just now is 4,800. Now it's 5,800, and this is the current location of the byte. So this is that's all for the AWS IoT Core part. Thank you.
Now I will talk about how to analyze and visualize the data of byte usage, because we would like to know if the byte needed to go through maintenance or not. But before we visualize the data in Amazon QuickSight, we need to download the data from DynamoDB. In the tables of DynamoDB, there will be a byte table, and we can explore the table item. Inside the table, there's byte ID, byte availability, byte usage, and their location. And then we will select all of them and click on download selected items to a CSV file. And after downloading the file, we can go to Amazon S3. Inside the Amazon S3, there's a bucket created for data visualization. And we can upload the CSV file that we downloaded from DynamoDB just now and the manifest.json file. The manifest.json file is for uploading a CSV file from S3 bucket to Amazon QuickSight, and the URI of the file to be uploaded is pointing to a CSV file located in the S3 bucket. And this will be the S3 bucket name, and the selected CSV is the file that we downloaded from DynamoDB. And after that, we can go to quick site and select new dataset from S3, and then the data source name will be inside, and the URL of the JSON manifest file can be obtained in here, and then click on copy S3 URI and paste it here, and then connect, visualize, and create. And to see if the byte need to go through maintenance or not, we can select byte ID, byte usage, and their location. And the byte usage is the distance travel of the byte. If the byte has more than 20,000 meter distance travel, then it means the byte need to go through maintenance. And that is all from me. Thank you.